All right, hello everyone. My name is Luis. I'm a forward deploy engineer at OpenAI, and I come all the way from Barcelona not to talk about data, not data warehouses, not pipelines. You already know that, right? You already know how to transfer data in and out. And now with Fivetran, you know how to ingest data in and out. At the end of the day, this is college, right? Today, I want to talk about AI agents. And most importantly, I want to talk about the intersection of data and AI. In other words, how can we make our agents truly reason over your enterprise data? But before we go deeper, let's make sure we are all aligned in one key concept, and a very much overloaded one, right? Which is, what is an agent? So we define an agent as a software entity that, using large language models equipped with tools, can operate in open-ended loops for long and uncertain time horizons. Because if you already know the exact sequence of steps to solve your task, you don't need an agent, you need a script. The essence of agentic behavior lies in ambiguity. You give the agent a task, a set of tools to interact with its environment, and let the model reason, sometimes for 20, 30 minutes, or even hours. All right, now we have a shared understanding of what an agent is. Now let's focus on how agents interact with data, with enterprise data today. For the last couple of years or so, the dominant use case has been conversational analytics. Think of that as ChatGPT, but constrained to your enterprise data sources. Here's a classical example, right? So it's a beautiful Friday morning, and your key user asks you, hey, can you create a report with actionable insights to understand why my sales are going down in APAC? You connect to your chatbot and start asking questions, right? But think, you are the one asking questions to the chatbot. You are the one analyzing drivers. You are the one identifying trends, and then writing a polished report with those insights. So the current generation of chat over data saves you time pulling data from dashboards, sure, but you still do most of the heavy lifting. Is this a truly agentic experience by the definition we gave earlier? Probably not. Because in reality, it's you, the human data analyst, running the show. So the question is, can we do better? And the answer is yes. With the rise of reasoning models, we can now go end-to-end, automating not just data access, but the entire workflow: analysis, synthesis, and communication. Let's see this example. So instead of giving a single answer, the agent now builds a trajectory to solve the full problem step by step. First, the agent might decide to do some context gathering. The agent starts by searching across sales rep document. They may be stored in a vector store. This gives the agent access to unstructured knowledge, like meeting notes, customer feedback, or playbooks. And that provides very valuable context for the analysis. Next, CRM data extraction. The agent might connect to a CRM, that may be through an MCP server, pull SCP data containing structured sales records. Then programmatic analysis. The agent writes and executes Python and Pandas in a secure sandbox environment to really understand what's happening there. Based on its finding, the agent forms hypotheses. For example, a drop in renewables is concentrated in one region. It then queries the data warehouse to validate or refute this hypothesis, iterating as needed until it has a clear picture. And finally, synthesis and reporting. The agent brings together information from an structured node, CRM, and data warehouse queries, It reasons over all of it. And then, finally, it authors a report that explains why the sales drop happened, and then suggests action to address that. This is how an agent goes beyond simple answers to build a custom trajectory to solve complex, long horizon tasks. Now, how easy is to achieve this in practice? The reality is very hard. We see organizations struggle because enterprise data is messy. It spans structured and unstructured data sources. Its relationships are implicit, undocumented, and often hard to infer. The same challenge a human analyst faces, disjoint schemas, unclear joins, missing metadata, your agent faces too. And even once the agent finds the right data source, it still runs into the same terms, meaning different things in different contexts, granularity mismatches, and implicit user knowledge that never made it to the query. So, what do we do? Is the party over? Not quite. We believe there is a missing piece. A kind of data oracle that can guide agents through complex, multi-source environments surfacing the right context for reasoning. It will show the agents where the data lives, and more importantly, how data is actually connected or interconnected. A layer that is independent of the particular use cases. So the cost of wiring a new agent for a new use case should feel incredibly low. Think of that as a context as a service layer, a foundation that lets any agent operate in an intelligent manner over your enterprise data. So, how do we build toward this vision? Let me offer a simple three-step path. 1, start small. Just a few structured data domains, maybe inside your data warehouse. What is important now is to prove value. You can use vanilla text-to-SQL tools to do so. Models like, frontiers model like GPT-5 works actually pretty well as long as you show them the data schema surface the right metadata. But soon, you will realize that you cannot be extracting custom metadata to show the model to make sure the SQL is OK every time. You will have to do that for each new use case. It's just not scalable. And it's also very costly to maintain. It's time to invest in a semantic layer, a component that introduces shared meaning and consistent access to your metrics across different data domains. Now, if you reach that step, you're probably more advanced than 90% of the companies out there, which is good. All right, step number 3. Finally, the data to AI nirvana. Bring in cross-modality context, unified, structured, and unstructured data, so agents can reason across the full enterprise data landscape. And yeah, that's the journey. Let's see how this might look with the technology that we have today. So we can build a proto-context as a service layer using OpenAI Agent SDK and the DBT semantic layer exposed via an MCP server. So at the top, GPT-5 and the Agent SDK give us powerful, flexible agents that can reason and act. Then we have the semantic layer built on DBT Cloud that translate DBT models into clear business concepts like revenue, top sales, etc. Through the MCP server, these OpenAI-based agents can call tools like list metrics or get entities, execute query to access govern business data. That's important. And at the bottom, you have a structured data warehouse. BigQuery, Snowflake, Databricks, Redshift, whatever you pick. So, and that component provides the underlying data foundation. So together, this stack terms raw data, into a structured context for the agents. All right. Who wants to see a demo? Live or recorded? Live? All right, all right, all right. Good, good, good. But before that, let me give you a bit of background here, right, the demo. I'm running a video games chain, right? But a very special one, a retro video game shop. You know, I'm kind of a games geek here. I have a lot of data needs, and I'm the only one running the show. So I cannot spend time like crunching data. But I did find time to put together a powerful multi-agent setup. So at the top, you have the orchestration planner agent that's coordinate the entire workflow. It delegates a specialized task to 4 dedicated agents. A data retriever agent, which connect to the dbt MCP server and the semantic layer on top of BigQuery, in this case, to pull structured data like my game sales. Then we have a web researcher agent, which gathers external information from the open web. Then we have a data analyst agent, which runs Python in a secure sandbox. And then we have a document authoring agent, which composes the final output into a structured, human-readable report. So together, this agent collaborate to autonomously plan, gather, analyze, and communicate insights. So let's see this agent architecture in action. All right, so here I am in BigQuery. Sorry, Google Cloud. Let me quickly go to BigQuery. I have a project called QualSLM agent. Let me open that. I have a data set called QualSLM dataset. It's pretty canonical standard dimensional model. I have my dimension tables, my fact tables. Have a look at customer, for instance. You know, click on preview. You know, nothing fancy there. Just sort my customer. Let's actually have a look at the product dimension. Let's actually query that. Let's maybe select distinct platform to see what we're selling there. All right, Dreamcast, Game Boy, Nintendo 64, PlayStation. You know, I did like put long trajectories playing, you know, Ocarina of Time back on the days. And you know, our classical order items kind of things. And then we have other tables such as stores and all. Again, classical dimensional models, I say. So the next thing that I did was putting together the dbt model on top. We quickly go to the studio here. Let me open that. Let me go to the metrics folder where I actually, using metric flow, create a semantic layer on top of my dbt models. Quickly, I mean, the purpose of this talk is not really going into the semantic layer, but let me quickly show you that. Simple YAML file that actually bootstrap pretty much everything using GPT-5 as well. Let's have a look at some of the metrics that I'm getting there. You know, for customer lifetime spend, unique customer, and for product things like, quickly go there, unit sold, product revenue. I really like this lineage graph there that show you, you know, all the metrics in a nice UI as well. All right, so I have my data in BigQuery, I create dbt models, I create a semantic layer on top of that, and now it's time to show that to the agent. So how do we do that? So I deploy a MCP server. Well, not deploy really, because dbt actually gives us that for free. It's like a managed service. So I basically configure that. Now I have access to that from agents. So let me show you a little of the code that I put together. So called coalesce. This is in source, backend, I believe, and agents. It's called agents. Okay. So we have a bunch of agents here. We have our data retriever agent, our data analyst agent, our web researcher agent, document author agent, and also our orchestrator planner agent. Let's go back to the data retriever agent. Let me actually show the instruction that I'm giving to this particular agent. Again, you know, something very standard. It's not like I'm showhorning anything specific on the prompt. But the interesting thing here, let me show you how do we show the MCP server to the model. So it's there. This is how we're instantiating the model. So I create an agent using GPT-5. I get the instruction, and then I give it access to the MCP server. OK, like just a few lines of code. So let me actually run the UI that we put on top. I should have a script here. Yeah, that one. Okay, so we put together this kind of terminal user interface, where on the left-hand side you see all the agents that I told you about. Then we will see all the traces happening, popping up there, and then we'll see the final output. So let's actually create a long horizon kind of task for my agent, something like create a report contrasting my Super NES games price with online market trends. I wanna make sure that I'm not leaving money on the table. Now hit run, and that will actually start in the run. So it's bootstrapping the orchestration agent that will call all the agent in sync. That may take around 25 minutes. I already ran that for you this morning, so I can show you the final output, which is exactly there. Yeah, let's have a look at the traces for a second. So the first thing that my orchestration decided to do, it was to call the data retrieval agent. And basically, this is the task that is passing by. Like compare internal Super NES sale price. This is internally querying the DBT semantic layer. But again, I'm not giving the model, hey, those are the metrics that you have to use. The model feels, understand the data, list metrics, understand which particular data should be used, and then query that. So after some time, the model, call the semantic layer and give me the result back. And I also give an additional tool to serialize the data in a CSV file. Then the orchestration agent actually decides to run a web research. Now it goes to the open web and start collecting information, I think, from a few websites, like eBay, I think, is using another one called Price Chart, which is kind of the golden data source for retro video game pricing, I guess. So, and then it's saving all the information as well in a CSV file. And then it called the code interpreted analysis. It has those two CSV files, load them into Pandas data frame, and start crunching the information to make sure how things working. Again, it's all controlled by agents. You see that the interaction that I'm here is minimal, really. So I start crunching some stuff, get something done, and then when it's finished, when the agent decided that it finished its process of crunching data, and now you will see in a minute that it will actually call the report creation agent. And you see the instruction there, like create a self-contained HTML report, like a SPA kind of page, to showcase all that information. So that's kind of the trace. As I say, it ran for 25 minutes, and we can see also on the final output, it gives me a summary of the plan. By the way, this is where the report should be, artifacts, reports. Okay, let's remember that. And then basically, this is what I did. It created a semantic layer. You see all those metrics, product revenue, units sold. It did web research on the price charting, eBay. Then compare other results. So, you guys want to see a result? Let's go. So, let me go back to that one. Maybe stop that. And open a new one. There we go. So that was in code, coalesce. It was in artifacts. It was on reports, CD reports. And there we go. Let me open that. There we go. Pretty cool, huh? Right. Let's actually have a look at what's happening there. So it gives me a summary, right? Comparing my price. And by the way, you will see something there called CIV. This is meaning that the games, is complete in box. It's kind of a geek terminology, I guess. There is also another term particular, which is seal. That game is even sealed, right? So you can command a premium price for that. And that's giving me a lot of insight, right? For instance, your console price is kind of good, all right? But look at Earthbound. This is a very classic game. It's kind of RPG. It's actually was made on the US, so it's super recommendable. But you will see, I'm selling that for $200, where, the price is actually 1,000. It's like I'm literally, losing money big time here. So give me a summary, but most important, even give me charts, right? It's called Matplotlib. I start to addressing all of that. I think that one is pretty cool, where you can see the orange dot here is the price that I'm selling, and this is the average price on price chart, and this is the average price on price chart new. So as you can see, I'm losing a lot of money with Hellbound. For Kirby, I'm actually kind of okay. For Street Fighter 2 Turbo, also kind of okay. And from Donkey Kong Country, kind of okay as well, right? So I definitely have to check this Hellbound thing to understand what's going on there. And not only that, give me a bunch of information there, and even some action checklists to make sure, hey, validate condition taxonomy, because I don't have that on my data warehouse, and that seems to be like a key metric to us, right? So definitely I will check that. A few other things, right? Cool, yeah, so that's the demo. Let me quickly go back to the slides. There. Yeah, just want to end like telling you guys what's new with agents at OpenAI. So literally last week, in our Dev Day conference, we announced a bunch of exciting features. We announced Agent Kit, which is a new way to build, deploy, and optimize agents at OpenAI. Let me start with the bottom, with the build phase. So inside Agent Kit, we have now Agent Builder, which is a low-code experience. So teams using Agent Builder can easily compose tools, model, prompts, and guardrails to create your agents. And then with a simple drag and drop kind of environment, you can start defining your agent architecture, exactly like I did on the code before. It's fully customizable. You can also add guardrails, a bit of conditional logic. Even I told you guys about that it's very important that the workflow should be as much as possible delegated to the agent. Sometimes you need some kind of conditional guardrails on between to kind of guide the agent a little bit better. So that's fine. It supports versioning as well. So yeah, it's pretty cool. So once you have your agent created, you have to deploy. See, building UIs like ChatGPT is pretty terrible, right? So you can bootstrap something very quickly with React or whatever, but actually level that up, to the experience that we have at ChatGPT is no easy thing. So with ChatKit, which is also a part of Agent Kit, you can take those agents and deploy in user-facing experiences that provide a clean, flexible interface layer. You can also add custom widgets, integrate client-side tool as well, to support all those agent-rich interaction. Also like upload data, session management. You can actually provide like a SQL database behind that, and all the traces will be saved there. It's pretty cool. And finally, you build your agent, you deploy your agent, and next thing is optimize. Through integrated evals, teams get observability, so you can kind of further optimize your experience there. You can trace agent behavior using LLM graders as well, and continuously tune performance, closing the gap between build, deploy, and optimize. So together, these three agents make it fast and reliable to build production ready AI agents. All these tools, as I say, they're part of Agent Kit, and you can use them today. All right, guys, so I hope you all learned something new today. It was my pleasure being here today with you, so thank you very much.